If I asked Theodore, my cat, what the definition of a linear function is, you know what he'd say? He wouldn't say anything. He doesn't speak English. But if I asked you the definition of a linear function, you might say that a linear function is a function whose graph produces a line. Linear just means line. Okay, linear line. Linear function means line function. The linear functions are always going to look of the form f of x equals mx plus b. Most of us have seen this before. Y equals mx plus b. That's a line. And b is going to be the initial value. You may have heard it called the y-intercept or the starting value. With a lot of applications, that b value will represent that fixed cost as well of that function. And m is going to be the constant rate of change. Any line will have a constant rate of change. If the slope or rate of change is not constant, it's no longer a line anymore, right? If your slope is changing, maybe it'll look like this. Well, that's like part of a parabola or something. If the slope is constant, by definition, the steepness being constant has to be a line. All right. Now, we do have a note here that this textbook really likes to flip things and say f of x equals b plus mx. They mean the same thing. But this b plus mx, which is actually what we did over here, usually makes more sense for how we talk in like real language skills. Again, we established in 1.3, I don't have real language skills. But and then so this kind of makes sense, right? We always have to pay $114, and then we pay an extra 1.6 cents for every gallon of water usage. So you can see it either way. They're both fine. They're both the same. So let's tie things into 1.3. Remember, a function's increasing if it goes up from left to right. So if a line is going up from left to right, it'll look like this. What do we know about a line slope or rate of change if this is the case? The idea is that the slope is going to be positive. Positive slope. A linear function will be increasing if it has a positive slope. It'll be decreasing, well, if it has a negative slope. Let's do some examples. Actually, I don't remember how many examples we have in this video. All right, just this page. I literally made these notes like 30 minutes ago, so I should remember, but that's not my strength. So we're going to start producing a new model of custom wheels. And these wheels, the company is going to have to purchase $30,000 in new equipment to start producing this model. After that, each wheel is going to cost them about $40 in supplies and labor. We're going to write a formula for the total cost. Again, a lot of times for variables, we use a single letter for a variable. You can use 2 letters for a single variable. That's fine. The total cost, known as TC, of producing Q wheels. All right, so the total cost is going to be a function of Q. So again, just like f of x, we can write TC of Q. My C's sometimes look like parentheses, I'm sorry. TC of Q is going to be something, the fixed costs plus the variable costs. Just like we did with the water. Well, if we're producing wheels, well, we do have to pay for this equipment. So no matter how many wheels, and when we buy the equipment, basically, if we produce any wheels, right, we're going to have to pay that $30,000 for that equipment. But then there's also a variable cost as well. Every new wheel is going to cost $40 for supplies and labor. So we're going to write it as 40 times Q, making sure that these variables are the same. It's very tempting to write X's, but if Q is the quantity of wheels we're making, let's make sure to be consistent. I always mess that up. You'll probably see it quite a few times in this class. All right. And again, whenever you're making a formula like that, you can do some gut checks, right? Like, okay, if we make one wheel, well, it should be the 30 grand and then $40. And yeah, if you plug in 1 into this formula, you'll get 30,040. 2 wheels, 30,000, and now $80. And yeah, if you plug that in, you'll get 30,080 bucks. Okay, so you can do some quick gut checks when you get something like that. What will their part B? What will their total cost be in the first year if they expect to sell 240 wheels? Well, we're going to also say there's an assumption here that we're going to expect to produce 240 wheels. Although realistically, right, this is where one of the breakdowns between math and actual business is, right? Sometimes mathematically we're going to make some assumptions like, oh yeah, if you're going to sell 240 wheels and you're going to make 240 wheels. But in reality, right, if you would want some buffer, okay? So if you want to account for that buffer, think, oh, let's have a 10% margin of error or something like that. And you want to actually create 262 wheels. I'll give credit for that, okay? But let's just keep things a little simple right now. We're going to say, well, the total cost of 250, right? Q is the quantity of wheels we're creating, which we're going to assume is the same as the number we're selling. But again, that's just an assumption. The total cost for 250 wheels, well, it's going to have to be that $30,000 plus 40 times Q, which is 240. We just type that into a calculator, okay? And then we try to find where I put my Desmos. We find it. All right, 30,000 plus 40 times 240, 39,600. So the total cost will be this. Answering it in a sentence is usually the best, but I think sometimes if the answer that I box is the direct, like if you think about having a conversation with someone, a sentence sometimes makes sense and a sentence sometimes isn't necessary. For example, if your boss says, hey, Jason, what's the total cost going to be in the first year if we want to sell 240 wheels? And you answer $39,600. $39,600. That's a complete answer. Okay, so in this case, I don't feel like we need any more words. We'll pause the video now and do this next problem. Again, you can make any assumptions you want. I'm going to assume the simplest situation possible. About we're making 40,000 and we're spending 39,000 a year, and with the rest of our money, we're just burying it in a hole in our backyard. We're not investing it. There's no market volatility. This problem could get pretty complicated. Just keep it simple. All right. Write an equation for the amount of money you save after Y years if you start with nothing. Relatable sometimes. All right, pause the video. Go get it. Okay, so the amount of money, you could call that whatever you want. You could call that M for money, D for dollars. I don't know. S for saved. Whatever thing you want. I'll use M. The amount of money that we have after Y years, well, we start with nothing. Remember that B value, right? We write as B plus MX usually. In this case, our variable is Y. The B value is just your starting value. Well, we start with nothing here. M is the rate of change. So how much money are we saving every year? Well, if we earn 40K and we only spend 39K, we're saving $1,000. So it's going to be $1,000 saved every year. And we can simplify that a little bit. That the money after Y years is just going to be $1,000 times Y. And the problem didn't specify. We're going to say M is just in dollars. That's the first part of this answer. Another answer, by the way, is you could have written M of Y is just equal to Y, where M is in thousands of dollars. So if you don't like writing zeros, this is another potential answer. All right. And a lot of math people love doing things like this because we don't like writing we don't like writing anything. We don't like writing words. We don't like writing zeros. We love abbreviations. So that's why it's important to specify, because both of these equations are valid. But you do have to you have to be clear about what units you're talking about. Oh, there's no part 2 of this question. That's just the question. Well, we're done with the video. Let me know if you have any questions about any topic in this video, and have a good rest of your day.